Okay, so we're starting with 4. I had made a mistake. I forgot I wanted to, stupid focusing, change this question. So can you please make this, instead of the word circumscribed, please write inscribed. So that's why I had to stop the video and restart. That's why you guys have 2 videos. Sorry. All right, let's try this now again. So now you have a circle. It's inscribed. So that means the thing on the outside is the hexagon. So draw the hexagon. And then your circle is inside. Make it inscribed, so try to touch all of your things. I just want you guys to understand the difference between when your circle is outside as opposed to when it's inside, and how it, like, the different things vary. So we'll leave that up there and I'll compare it. All right, and as you guys know, you're drawing your triangle. The radius is 10. So if you guys recall, in this problem, when your circle was outside, circumscribed, the radius was your hypotenuse of the triangle, right? The radius was the radius of the circle, your radius of the polygon. When your circle is inscribed, now the radius is your apothem. So you actually found your apothem. So when you write your formula, 1/2 AP, 1/2, you already know your apothem, which is 10. Big difference, and that's why I wanted to change that problem, and I forgot to change that problem. We'll just cross, this is your second one. Okay, so please understand again, circle outside, radius is your hypotenuse. Circle is inside, the radius, is your apothem. All right, let's continue the problem. All right, so now we know this is 90. Let's take this out one more time. We got our 90 here. We have our 10 here. It's your hexagon. You should know by now how many degrees is here. 30 and 60. If you don't know how we got that, go back to my other problems and look. 1, rod 3, 2. I'm just going to go like this. Okay, so this one's our harder one. We want to go from rad 3 to 1. So we're dividing. 10 divided by rad 3. We know we cannot have a radical, so we rationalize. Times it by rad 3, times it by rad 3. 10 rad 3 over 3 is just right here. Let's put that in there so in case you're not sure. So this is 10 rad 3 over 3. I want an actual side, or here's another thought. Question. If this is 10 rad 3, so we want to multiply it by 2. And then you want to multiply it by 1, 2, 3, 4, 5, 6 to find your actual perimeter. So you can say you want to multiply it by 2, then times it by 6, or in reality you could say 12. If you're like, I don't understand, I will go slow again. If I times it by 2, you get 20 rad 3 over 3, and then times it by 6 to find my perimeter, which is why I said you can just times it by 12. Your perimeter is 120 rad 3 over 3, which I want you to simplify to become 40. So 40 rad 3. Okay, so then we do this again. You do half of 10, which is 5. 5 times 40. 20 rad 3 is the area of your polygon. If I asked you for the area of the shaded, and I did the shaded here again, let's do that. Oh, I shouldn't go all the way there, but let's pretend I said, kind of ran out of room, the area of shaded. Okay, if I asked you for the area of the shaded, which this was supposed to touch, so please make sure you realize that. It's all of these. You want to take the area now of the outside shape. Yikes, that should touch. That's okay. The area of the outside shape, which is your polygon. So 200 rad 3. Then minus the area of the circle. Well, the radius is 10, so now this is 100 pi. Again, it's kind of the opposite of what we did in this problem above. Let me just cut that off a little bit more. It's kind of the opposite, you know. In this one, we took the circle minus the polygon. This is the polygon minus the circle, your outside shape minus your inside. All right? All right, number 5, last one before I show you one of the last things of this lesson. We're almost done. Okay, the ones you're not going to like. Pentagon. You should hopefully realize when I say pentagon means you're going to have to you're going to have to do trig. We have 2 different problems. Let's see. Okay. A regular pentagon is circumscribed about a circle. So the pentagon is outside your circle. I don't know why I did that, but okay. Pentagon. And then, yikes. Not the best. Outside a circle. Okay, let's do this again. Remember, the triangle is always of the polygon. The radius, the regular pentagon is circumscribed about a circle whose radius is 10. This is going outside, so this is your 10. Find a side and then use the results in A to find the area. Okay, part A is to find me a side. I'm going to take that triangle out one more time so I don't go sloppy. 10. So you want to look for this, correct? Okay. So we find our central 360. It's been a while. So 572. Take the 72, divide by 2. Remember, because that's finding that whole thing is the central. I only want part of it, or half. 36. So you're going to want that calculator handy again. Realize you have opposite adjacent. So we are doing tan. Tan 36 equals opposite over, adjacent. When we cross multiply, you should get x equals approximately, we'll say 7.2654. Sorry, that's only for this. That's that. I want to know what a full side is. So you're going to take your number and just multiply it by 2 to get me your full side. And wants us to round to the nearest tenth, so 14.5. Part 1, done. Okay, part B. Use the results. I want you to use this. You don't have to go back and get your decimal version. I'm going to have you use this to find your area. So let's write our formula. Okay, 1/2. Well, you know the apothem, it's right here, is 10. Perimeter. Side is 14.5. Let's now take the 14.5, which is our side. More or less is me guiding you into finding the area. So put it on your calculator. It wants us the nearest integer. Integer is a whole number, 363. Let me just add. I know you guys don't like when I add, but I'm going to add another question one more time. I'm going to say the area of your shaded. So let's color. You guys will like coloring. If I want the area of the shaded, we are taking the area of the outside, which is your pentagon, minus the area of the circle. So we can just say 100 pi. And you can leave it as exact for here. No, actually, I don't want you leaving exact because that number isn't exact. That's approximately. We can just say using the answer from here, you calculated this, find this the nearest tenth. So we'll say 48.8. I really wouldn't want you to use a number that you actually rounded, but if I ask you for the area, we'll say using, if this is a part C, using answer, I want to make sure I tell you that from part B. That's when you would use the 363. Otherwise, you know you'd have to use your rounded version. I mean, all the decimals. Okay, so just a little bit more work. You have to still know your trig, but it's the same kind of concept. Okay, last part that we have. It actually hopefully should be easier for you all. I know it says 2 questions, so sorry, I'm asking you a 3rd question, and then you're done. I know you guys probably like, oh, that's a lot. All right, area of composite figures. So what is a composite figure? I move it a little bit. A composite figure for us is going to be a figure that can be separated into regions that are basic figures. Basic figures, like for example, rectangles, squares, things that we've already found. Circles, triangles, trapezoid. And what you guys end up doing is you find the areas of these basic figures. It's pretty self-explanatory. I think you guys would know this. And add or subtract. Oops. Okay? So let's take a peek at question 1. So I know there's only 2. I am adding a third one. Don't worry, it's not going to be that bad for us. These are actually easier than the other ones. So here you guys have your picture. What we want to do is we want to separate this into two different basic figures. So I'm going to go like this, and I'm going to have a rectangle, and I'm going to have a trapezoid. And in this case, you should know it's isosceles because those 2 sides are marked. What you also could have realized you probably could do is I could have made this a rectangle and 2 triangles. Whatever you see first. So I'm also going to give myself a note. Rectangle, you're adding, plus isosceles trap. Let's review. Rectangle, length times width. Isosceles trap, 1/2. You learned this the other couple days ago. Height, base 1 plus base 2. Pretty simple. Let's put our numbers in. 10 times 6, 60. 1/2. The height, well, that's not bad because this whole thing is 18. If this is 6, the height of the trapezoid is 12. 12, base 1 is this, base 2. And you should get 100, I think, in 80. And then your final answer is 240. There you go. Like I said, I know a lot more work, but it's very simple. Okay? Second question. The way I see this is, actually, before we continue, I want you to change this. So I'm going to make this a little bigger. That's going to be 5. Change this to 12. Otherwise, you guys just get some ugly numbers, and we don't need to do that. I'm going to put, a line here. So I'm going to say I have a right triangle, and I want to emphasize right triangle to make our life easier. Then I'm going to go like that. Since these 2 sides are the same, and then opposite sides, this is going to be my square, and then this is half a circle. So I'm going to write that as my heading. Remember I told you guys I like writing headings? Right triangle, that doesn't look like a triangle, plus, we'll say square, plus 1/2 a circle. Now, the reason why I wanted to stress the right triangle, because the beauty about a right triangle is since it's 1/2 base times height, the fact you have a right angle here, we all know that this can be the height or this can be the height because you have the 90 degrees. So we can just take leg times leg over 2. That's in a leg. Oh, God, it looks like an H. So my legs, 5 times 12 over 2. And you guys got 30. Square. Well, it'd be nice if you guys knew side squared. So you have, don't know my side. This is why I changed it. For you to find this, you just have to do Pythagorean theorem. 5 squared plus 12 squared equals your c squared. You should know this is one of your triples, and hopefully you know it's your 13. Oh, I wrote something different. So we have 13 squared, 169. Okay, then that means this is 13. Let's write our formula. Pi r squared over 2 plus, we have pi radius, half of 13 is 6.5 squared over 2. And let's again, just to reiterate, let's do exact. So I messed this one up, so I have to use my calculator. 6.5 squared divided by 2. So with this, I get 21.125 pi, 30 and 169. You guys had that. And you have 199 plus 21.125 pi. And there's your answer for that one. Okay. Here's your third one. We're almost done. I wanted to throw in one where you guys were subtracting. All of those were adding. So please draw this as your picture. Almost looks like pants. You know, like when you were younger and you'd be drawing. Oh, can't see. There you go. Okay, so draw that. And then I'm going to put these numbers in here, and then I'll wait for you. 1 and 8. Okay, so please draw that down. And I want to find the exact area. So what you're going to do with this one is I'm going to find the area. This is a trapezoid. I'm going to find the area of my trapezoid minus this, because this is what, oops, this is what I want to get rid of. So minus my triangle. All right, let's write my formulas in. 1/2 height B1 plus B2 minus, well, this triangle is a regular triangle, isosceles, so we're just going to write base times height over 2, or 1/2 base times height. All right, I have 1/2. Height, don't know it. I'll put that in a moment. And then base 1, we can say is 8, base 2, 10, 11, 12. Okay, so here's the hard part. For us to find the height, the only way that I can see it is if I can go like this, and then I have the 1, and what I can work with here is that triangle. If you guys see another way, more than happy to tell me. So I can do the triangle, and that'll find this height, which actually is going to help me for this, so I think this way is good. And then you just have to add 1. All right, so I'm going to take that triangle. This is 2, this is 6, and this is 6. And I want to find this height. We know we have an isosceles triangle, so it bisects the base, and this is 1, and this is 1. So what we're going to have to do is Pythagorean theorem. C squared, which is 36, equals 1, because I had to bisect it, minus x, plus x squared. So 1 squared is 1, minus it. You guys should get x squared equals 35. So x is the square root of 35. So the height of this triangle, I'm just going to put it in a different color because it's important, is the square root of 35. While I'm there, I'm just going to put that in my problem. The base of the triangle was 2. The height of the triangle was radical 35. And you want to divide it by 2. Base times, oh Lord, stuck to my hand. Base times height over 2. Now this was rad 35, but that's not the height of the trapezoid. You want to add 1 to it. So what I would recommend doing, because it's going to look funky, is let's figure out, so we know 8 times 12 is 20. So we have 1/2 of 20, and then you want to take this 1 plus radical 35 is your height. It looks like I raised that to 20. So 1/2 of 20 is 10. So really what you're doing is 10 times 1 plus radical 35. You guys use your calculator. You end up getting about 60, not about, you end up getting 69.16079 ... When you put this in your calculator, you should get 5.91607. You guys know don't round. When you put it all in, your final answer is about 63.2 to the nearest 10th. I don't know if I said it exact or not. And that is your lesson. So that's area of your composite figures, whether you are subtracting one, break them up, or whether you're adding them. Give yourselves titles, headings, write your formulas, help yourselves out for those types of problems. Hopefully you guys were okay with the lesson. I know it's a little bit more challenging, but hopefully it made sense. All right, I'll see you guys another day. Bye.